All right, we are going to learn how to balance equations. First, definition, what is a chemical equation? Well, a chemical equation uses formulas to describe what is happening during a reaction, right? Remember the law of conservation of matter, which says matter cannot be created or destroyed, all right? That means the total number of each element must be the same on both sides of the reaction. So, if this is a reaction, hydrogen plus oxygen forming H2O, this, if we counted the number of atoms on both sides, this is not balanced, right? We have the hydrogens to be the same on both sides, but the oxygens are not. So, when you balance an equation, we're just going to write in numbers. We'll add a 2 here and a 2 here. And so now, 2 times 2 of this formula, but each of these formulas has 2 hydrogens. We have 4 hydrogen atoms on the right side. Do you guys see that? Okay. And then here we have 2 times H2. There's 4 hydrogen atoms here as well. So the hydrogen is set. Now, because we have 2 oxygen atoms on the left side, by putting a coefficient of 2 here, that now gives us 2 oxygens on the right side, which reminds me, I should probably mention this. Anything that you begin with, we refer to as reactants. And the reactants are always on the left side. Anything that is made, we refer to as the products. And the products are always going to be on the right side. Okay? So always, when we refer to reactants, you should know the reactants are on the left side of the arrow. The products are on the right side, okay? All right. I wonder if I should... Okay, so here's something I need to mention here. And it might come up later, but just to explain this now since it's here. There are 7 elements that are written with a subscript of 2. Hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. Right? These are known as the Hankel-Briff elements. They exist as diatomic molecules. And we've drawn these a bunch in our bonding unit. We've drawn the simple molecule that looks something like this, right? Where we count up the valence electrons and we see that they're 2 of the same atom bonded to each other. So if you're ever wondering why you see an element and an element has a subscript of 2, it's because if it's one of these 7, that's how it exists in nature. And so that is how it must be written. Right? And even from biology, you've probably seen oxygen written as O2, for the longest time. So why is it written that way? Because that's how oxygen exists, as a molecule of 2 oxygen atoms bonded. Okay? All right, just wanted to get that out there. Remember Hankel-Briff. That's going to be important to remember later on, but I'm bringing it up now a little early. There are 2 rules to follow when you're balancing equations, right? And they're important rules. There's only 2, but they're very important. You must use coefficients when you're multiplying the numbers of atoms. And when I say you must use coefficients, that means you will never change the subscripts in a formula. You can only change the number of things. You cannot change what the formula is. So example, going back up to this reaction we just balanced up here, right? When I balanced, in order to balance this, notice how we use the coefficients here and here to balance this equation. All I'm doing is I'm changing the number of times things are multiplied. Notice that what we did not do, I did not do this. Wrong place. I did not do this. Right? This, I can't just stick a 2 onto a formula. I cannot change a number in a formula because that changes what substance we are representing. You can't magically turn a compound into something else. So you will never change subscripts. You will only change the coefficients in front of formulas. Okay? So, the best way to learn how to do this is quite simply trial and error, but There's some tips, and I'll walk you through them. So if we want to balance this first one, generally speaking, find the largest looking or the most complicated looking formula. And here, I would say this is the largest formula here. It simply has the most atoms, okay? And say, all right, I see there's 1 aluminum and there's 3 chlorines. So what I want to do is I'm going to try to make the number of chlorine atoms the same on both sides. So currently, there's 3 chlorines here. So to make there be 3 chlorines on the left side, I will need to multiply the formula of NaCl by 3. Okay. Now the chlorines are taken care of because there's 3 chlorine atoms on both sides. Now, by doing that, now I have 3 sodium atoms on both sides. Right? 3 sodiums. I'm sorry, I have 3 on the left side. I need to make sure there's 3 on both sides. So I come back to the right side, and I add a coefficient of 3 here. Now the number of sodium atoms is the same on both sides. And there's one element left that I have not addressed. It is aluminum. And currently there is 1 aluminum here and 1 aluminum here. And you don't need to write the 1. The 1 is implied if it's not written. And so now this formula is balanced. You'll see that as you go through the process of balancing an equation, you're gonna start one place, and eventually you'll be touching every element. And when you get to the end, after you've touched each element and all the numbers work out, that's how you know you're done. So let's try the next one. This is a little bit of a shorter reaction. So we're starting with N2O5. Specifically, I'm going to start with the oxygen. Okay, so notice that we have 5 oxygen atoms on the right side. On the left side, oxygen comes in increments of 2. So if it comes in increments of 2, and on the right side it comes in increments of 5, how do you fix this? Let's try to avoid decimals or fractions. Let's try to use whole integers then. Tia? Yeah, least common multiple between 2 and 5 is 10. So let's get 10 oxygens on both sides. So to do that on the right side, let's put a 2 here. And by doing that, I now have 10 oxygens on the right side. And to get 10 oxygens on the left, I will put a 5 here. So the oxygen is not taken care of. Now we just have to fix the nitrogen. How do you fix the nitrogen? Just to put a 2, yeah. So we have 4 nitrogens on both sides. I'm guessing probably half of you did balancing equations in 8th grade? Maybe? Yeah, okay. So, I mean, granted, they can get more complicated, but, we won't get there for a while. All right, so as far as tips, I mentioned this one already. Look for the most complicated molecule, work from there. We've talked about how you cannot change formulas. You can only change coefficients. If you see polyatomic ions make balancing an equation easier, believe it or not, right? Because polyatomic ions tend to stick together, and you're going to see that in a minute. So here is where I'm going to insert a bunch or another page, and I'm just going to give you a bunch of practice to make sure that we got this down. So, okay. Balance the following. for that last one, I'm going to point out that water, H2O, sometimes is written as HOH. Sometimes it makes things easier to see. All right, so let's start going over this. So for the first one, I'm going to start here because that is the biggest formula. And so right away, I notice a couple of things. I notice that there's oxygens come in increments of 2 on the left side. So I'm probably going to want 2 oxygens on the right side. So let's put a 2 here. And that takes care of the oxygen. All right, now the oxygen is balanced on both sides. By putting a 2 there, that now means I multiply my Na2 by 2, so that's really a total of 4 sodiums, which we can fix pretty easily just by putting a 4 there. Make sense? Okay, so that's the first one. All right, for the second one, let's start with this guy, MgCl2. Okay, so I have 2 chlorines in the compound. On the left side, I have 1 chlorine in the compound. So I will need 2 chlorines on this side, so let's go ahead and put a coefficient of 2 in front. And by doing that, now my hydrogens, I have 2 hydrogens on both sides, so that's good. And then the last element to touch is magnesium, and there's 1 here and there's 1 here. So that didn't need to do too much to balance that one. Okay. All right, and then our last one. Okay, so there's a bunch going on here. This guy looks like a good place to start. So remember that when you have more than one polyatomic ion in a formula, you use parentheses, and that's why this guy has parentheses here. So there's 2 phosphates in this formula. On the left side, here's the formula that contains phosphate, but there's only 1 of them. So let's multiply 2 here. And so now that gives me 6 hydrogen atoms. Okay? And so where I'll find hydrogen is here, because it's this hydrogen that we're multiplying. So 6 and 6 on both sides. And the OH part, this is a polyatomic ion, right? And it wasn't so obvious to see it's a polyatomic ion when we wrote it as H2O. That's why I kind of wrote it in this alternate fashion. So if there's 6 OHs, that means I come back here and I see these OHs here, but I need 6 of them, so let's use a 3 here. And now the calcium is 3 and the calcium is 3, and now we are done. And so now everything is balanced. So you guys see how I'm doing? There's a flow to this, right? Left, right, left, right. Okay, you go back and forth, okay? All right, ready to kick it up a notch? Let's do one mildly more challenging. This is the equation for the burning of natural gas. So when we use Bunsen burners, or when you use like your furnace or your stove, right? This is the reaction that takes place. Now, the one thing about this that makes this tricky is that, do you see how oxygen is found in 3 different places? That's going to make this hard. But if you follow a certain order, it's not hard. Whenever you see an element that occurs more than twice, you balance that element last. All right? Let the process sort it out for you. And this is actually a tip given right here. Nope, just kidding, here. Look for an element that occurs in only one product and one reactant. Balance that element first, then balance the other ones. So in other words, oxygen is the one we want to do last. This is actually what we call a combustion. And we'll talk more about what combustion is later, but this is a combustion reaction. And the way that you can tell a combustion reaction is that you have a hydrocarbon compound, which is this guy, reacting with oxygen. So, examples of other hydrocarbon compounds: C2H6, C2H5OH, C4H10, right? When it has lots of C's and H's, that's a hydrocarbon, okay? And so hydrocarbons, when they react with oxygen, they always make the same products: water and carbon dioxide. So, in combustion reactions, start with carbon. So, all right, there is one carbon on the left, there's one carbon on the right. Okay, well, that was done. That's easy. It's not always going to be the same, but, you know. Next, do hydrogen. Okay, so now I have 4 hydrogens on the left side, and I only have 2 hydrogens on the right side. Okay, so to fix that, let's multiply the water by 2. And so now I have 4 waters, or 4 hydrogen atoms. And now finally we do the oxygen. So now I can start counting up the oxygens on the right side. 2 waters means two oxygens here, plus the 2 here, so that's a total of 4 oxygens on the right side. So that means I can just put a 2 here, and that gives me my 4 oxygens on the left, and now I should be done. Okay, so if you recognize combustion, start with carbon, then hydrogen, then oxygen. Okay? So let me give you another one for you to do on your own. Oops. All right, take a crack at it. Anybody want to offer up what they have? Taylor, what do you think?
I said 2, then 7, then 4, and then 6.
Okay, so let's check that and count them up. So 2, 2, so that's 4, that's good. 2 times 6 is 12, so 2 times 6 is 12. Okay, that's good. 6 O's plus 8 O's is 14 O's. Yeah, good. Good job. So, she offered that up pretty quick. I'm gonna erase that for a second and just kind of go through the process of this, because this one could have been tricky. right? So watch. We said start with carbon first. So that means a 2 here. Did everyone see that? There's a 2 here, so you would put a 2 there first, okay? And then we said oxygen or hydrogen next. So there's 6 hydrogens here, but there's 2 here, so you would want to put a 3 here because that's 6 hydrogens. And now we said do oxygen last. So 3 oxygens and 4 is 7. 7 oxygens, right? And so you come over here and you see your oxygen only comes in increments of 2, which means if you wrote 3.5 times 2 is 7, but we're not going to be using decimals. You need to use whole integers. So to fix this problem, multiply everything by 2, right? And so that's why this was a 2, that's why this was a 7, this was a 4, and this was a 6. And this is something that is going to happen with combustion reactions specifically. Okay? So that's why it's kind of important to recognize if something is a combustion, right? Because there will be often times where you'll have like a 3.5, a 2.5, a 4.5, and you should know that you need to multiply everything through by 2. How are we doing? Good? Okay. All right. So that's what I wanted to cover today.